Okay, good morning everybody. So we will do some practice on the chapter 8, system of equation. So first question is consider the table of value given here in this table, and the question is asking us so use the table to determine a solution to the system of equations. So we have this system. So in this question, the only thing you need to look where you have two similarity between these two tables. So the only row that have similarity, so we have 0.5, no, 1, no, 1.5, no, 2, yes, you can see this one is similar to this one. So this is the answer for this question. We can go further and look if there is another one. No, there's just one. Perfect. Verify this solution graphically. So to do that graphically, we need to go to graph and graph these two equations. So the first one is minus 1.5 x minus 2. So this is the first graph. The second one is minus 2 parentheses x minus 4 everything square plus 3. Good. So we have our two equations. So we graph both of them, and the answer, the question is asking us to find this solution. So you can look, what is the question again? So verify the solution. Yeah, so we need to check if actually this is a solution or not. So going back to our graph, yes, absolutely, you can see here that we have this point here, which is the intersection between two graphs, which is minus 2, 2 minus 5. X is 2 and y is minus 5. So the other question is, what is the other solution to the system? To see that, go back to the graph and look for the other intersection. So this is the another intersection. And if you just see the intersection between two graphs, you will see the x is 6.75 and y is 15 minus 15, 125. Good. So let's go back to our questions. For the question number 2, state the number of possible solution of each system. Includes sketch to support your answer. So a system involving a parabola and a horizontal line. So if we have a system that contain a parabola, so for example, this is my x. No, let me do this. Remove this. So if I have equation like this, and my graph is a parabola like this. So the first one is like this. So my parabola is like this. In my equation, horizontal line. So I will just draw a horizontal line. So this one is actually touching in one point. So there is one solution. So we can see in this example, we have one solution. Another example is if our parabola is a little bit far away from the equation, so we can see this parabola. Let me remove the parabola. Okay, so suppose my parabola is a little bit up. So this is my parabola. So in this case, there is no solution. So we can see there is no intersection between the two graphs. So there is no solution for our system. The third example is when you have your parabola is actually cutting line into points. For example, like this. So now my parabola is cutting my line in 2 points, in this one, in this one. So in this case, there is 2 solution. Perfect. So next question. So we have all of them. So horizontal line, a system involving 2 parabola that both open upward. So the first one is just a simple parabola and a line. The other question B is 2 parabola. Same thing, same interpretation, and it's just you will have your line, x and y are lines like this. And the first example, I have my parabola, first one is like this, and my second parabola is like this. So in this case, there is no solution. So they are not touching each other, so there is no solution. Okay, the second possibility case is your parabola, first parabola is like this, and the second parabola is like this. Now you can see there is 1 point which there is one solution. Okay, the third example is if you have your first parabola is like this and the second parabola is like this. So now we have 2 solutions. We have intersection here and you have intersection here. So this is question B. Okay, so now let's see question C. A system involving a parabola and a line with a positive slope. So if you have a line with a positive slope, for example, this is my lines. We are talking about number C. So if you have a line with a positive slope, that means my line is doing like this. Okay, this is my line. I have a positive slope and a parabola. Same thing, same interpretation. First one, not touching at all, no solution. The other one, touching 1 point like this. Your parabola is not touching just in 1 point. No, this one is actually will be touching 2 points. Second one is touching just in 1 point. So like there is no upward or downward. Inverted parabola, yeah. So if my parabola is like this, my parabola is looking like this, touching in a simple point. No. Like this, I have my parabola coming down and touching 1 point. So now I have one solution touching 1 point. The other case is 2 touching in 2 points. So this like this. So you have solution here and you have another solution here. Good. Now let's go to the next question. Solve each system of equation by graphing them. So we need to solve equation just by graph. So the first equation is 2 over 3x plus 4. Okay, so we're talking about this one. Okay, let me go to graphs. You can do this by using your graphing calculator, and it will be just same thing. You just follow the same thing. So 2x divided by 3 plus 4. So plus 4. Okay, this is my first line. The second one is minus 3x. Okay, okay, plus 6 plus 6, everything square. Okay, good. So this is the graph that we have. So to solve the solution for this, you can touch your touching point and you will see the solution is minus 6 0. Good. So and the next graph, so this is A. For B, let's remove this. For our B is x squared, so we have x squared minus 4x plus 1 plus 1. Okay, this is my first equation. The second equation is minus a half x minus 2 squared, so minus x x minus 2 everything square plus 3, no, divided by 2, okay, plus 3. Good. So this is my second equation number B. So if I touch this one and I touch this one, we can see the answer are 0 1 and 4 1. So this is your two answers. So let's see number 4. We will go to question number 4. Adam graphed the system of a quadratic equation y is equal to x squared plus 1 and y squared plus 3 on a graphing calculator. He speculates that the two graphs will intersect at same large value of y. Is Adam correct? No, he is not correct, and I will tell you why. So we have two equations. We have x squared plus 1 and we have x squared plus 3. X squared plus 1, let me graph them. So x squared plus 1 is actually same as x squared plus x squared plus 3 or 4 or 5 or whatever. Why? Because it is the same graph, it just we move it up. So we just take the same graph, which is actually x squared, which is just x squared, and we are just moving up, we're moving it up 1 unit or 3 units. So if I am moving my graph, the same graph 1 or 2 units, it will be the same one and they will always be parallel. They will never touch each other. And it doesn't matter if you put like x squared minus 5 or x squared plus another number, it will be the same thing. There is no touching at all. So question number 5. Solve its system equation by graphing. So I really show you how to graph. So you just graph both of them and you see the intersection and you will get the answer from there. It's just pretty simple, same as we just did up to now. So I think the first one you will have touching in one point. The second, why I'm telling that, because I can see they are almost similar, but just there is a up translation and there is one that was pushed a little bit there left or right. So they will both of them touch. They will both of them one touch the other just in one point. It is the same one, same opening, same thing. It's just touching in one point. One of them is going up a little bit and going to one side than another one. For number B it's you have a negative before 6, so it should be down, and the other one it has a positive, so one of them is down like this, and and one of them is up, so they will be touching each other in two different points. For C, you can see this is a line and this is a parabola. So it is a downward parabola with a line, which will be touching it in 2 points. Because this is equation of line, a line equation, and this is a parabola. However, these two are parabola and these two are parabola. Okay, good. So now question number 6. Let me remove this thing. Okay, question number 6. One engineer constructs side by side parabolic architecture to support a bridge over a road. Each over road has maximum height of 6 meter and the width with 16 meter. The river arch has a maximum height of 8 meter, but its width is 4 meters. So so we have two bridges. Okay, so we have one here, we have two bridges. We have the first one and we have the second one, but they just remove this section and put a metallic structure there. So this is the two bridge, but in reality they are two different parabola. So what is the question? Determine the equation that model each arc. Okay, the first thing, if we need to find the equation of a parabola from a graph, you need a point. You need to have a point. So for us, the first point that we have, so they say the width, they said the width of the first one is how much? Is 14 or 15? 16. So they said the first one, the width is 16. So let's see, yes, here. The width is the 16. That means the half of it is 8. So this is 8. So the first point I have here is I have x is 8 and y is 6. So I have a point which 8, 6. And I know the equation of a parabola. Let's do this in another page. Maybe we will have, yes, here we can do it. Okay, we know the equation of a parabola is y is equal, no, this is not good, so let me use another one. So y is equal to a number a times x squared. So this is the general formula for any parabolic graph. Okay, from this equation I can find I got my first point is 8, x is 8 and y is 6. So my x is 8 and my y is 6. The first information I got here is my parabola is looking down. So I know my a is negative, should be negative. Okay, so I just will solve for this. I will put my y here, my 6 is equal to a times 8 squared. And I can just isolate for my a. This means that my a is 6 over 8 squared, which is 3 times 2 over 4 times 2 squared. So I will remove one 1 2 from here, and they will get just 1. So my a will be 3 over 32. So 16 times 2 is 32. Perfect. So, and because I know my a is negative, so it should be negative. Okay, now I find my a. So I can directly go and write my equation is. So my equation is y minus y0 any point is equal to a times x minus x0. Okay, this is the general formula of a parabola. Okay, the first one, I always encourage you to use it to find a. So if you are looking for your a, use this formula. And when you want to build your equation, use this formula. So now I will build my equation. So I'm always using this point. So y minus y0, which is this is x0, y0. So this is both of them. So my y0 is 6 is equal to my a minus 3 over 32 times x minus x0, which is 8. And you can just write this as y is equal to minus 3 over 32 x minus 8 plus 6. So this is my first parabola equation. For the second one, we will do the same thing. Let me move this a little bit to one side. Okay, so just remove this from this section, and they will put it here. X, oh no. So x0, y0. Okay, now I will use the other section of the parabola. So the other part of the parabola, I need 2 points. So I can look for the middle one, which is here. Okay, and it is 24. So my points are 24, and my y is 8. Okay, good. So I have my point 24 and 8. I will do the same thing as just we did before here. So let me draw a line to separate these two. So this is the other equation for the other. So same thing, I will find my a. Perfect. So I got my a. So my a is minus 1 over 18. I will just go and write my equation directly here. So my y minus y0 is a times x minus x0, which is y minus my y0. y0 is this one. Now we are talking about the second y0. So this is x0, y0. This is for the other parabola. So minus y0, which is 8, is equal to a, which is minus 1 over 18 times x minus 24. So again, you can write it like this. Y is equal to minus 1 over 18 x times minus 24 plus 8. So this is the second equation. Okay, perfect. So question B, they are asking us to solve the system of linear equation. So let me erase all this thing. Okay, erase all this. Okay, so we can have some space. Okay, good. Now to solve this problem, we just need to graph them. So my y1 was minus, I think my y1 was minus 3 over 32 x minus 8 square plus 6. The other y was minus 1 over 18 times x minus 24 square plus 8. And you just need to graph both of them. Graph these two equations. Let's us graph them. So remove this. So the first equation is minus 3 x minus 8 everything square divided by 32. So this is my first equation. No, plus 6. There is plus 6. Yeah, plus 6. So just take it up a little bit. Okay, the second equation was minus x minus 24 x minus 24 everything square plus divided by 18 plus 8. Okay, good. So now I have my two bridges here, and you can see, if I make it a little bit smaller, you can see my two bridges here. So the first intersection we can see is this point. So this point is my first intersection, and you can see the solution is 14.081 and 2.53. So that is the solution. Okay, so let's see the next question. What information does the solution to the system give the engineer? So the first equation models the horizontal distance traveled. No, the intersection tells the engineer that the distance of the following or the footing from the other side of the road, like if we go to the first picture, so this information tells we are actually finding this point. So this will tell the engineer that your intersection point is high, like the length of it is 2.530 meters. So suppose this is meters, so it is high 2 point something meter, and it is like away from your original point of the first bridge. It is away 14 something. Here is 14.08. So they will know where to install this post, and they will know how high the post will be, and it will make their lives very easy. So this is number 5. Where is number 6? I think number 6 is in the other page. Okay, this is number 6. We just did number 6. Yeah, this is number 6. So we did number 6. We will go to number 7. So number 7, Caitlin is at the base of a hill with a constant slope. She kick a ball as hard as she can up the hill. Explain the following system models this situation. Okay, the first one, it is a parabola equation, and the second one is a line equation. So we know that she hit the ball like this, so it went from a point to another one, and we know that there is a hill, so the hill is like this, for example. So from here we can see that the first system equation is for the parabola, which is the trajectory of the ball or the object that she hit, and the second equation is the slope of the hill, which is a line. Okay, solve the system. So to solve this system, there is two ways. Either you graph it or we do it algebraically. But for the first question, you just this first part of question, you just graph them in your calculator, and you find the intersection of this parabola with this line, and the intersection is where the ball will like where the ball will land on the hill. So if she hit the ball like this, when the ball touch the hill like this shows you where the ball land on the hill. So now we will go do another exciting exercises, which are like first one, estimate the solution to the system of the equation shown in the graph. So we have two equations. We have one here and we have here. If you are given the graph like this in your exam paper, don't go crazy and try to graph it. No, you need to save some time. Just look to the where are the intersection, and intersection are actually the solution. So we have an intersection here and we have an intersection here. So this point is 5 and 6. So x is 6 and y is 5. So this is the first point. Okay, this is one solution. The other solution is here, is -3 and 2. So the second answer is 2 minus 3. So this is your second point. Just from the graph you can get them without losing time. Second question, solve the system algebraically. So now we need to solve it algebraically. To solve this equation algebraically, we need to make these two, like when they are when they intersect each other, that mean both equations are equal. So at this point and at this point, both equations, this one and this one, are equal. So this y is equal to this y, and this is exactly what you will start with it. So you put just x squared minus 6x plus 5 is equal to 2x minus 7, and you put everything in one side, so it will be x squared minus 2x minus 6x plus 5 plus 7, which will be x squared minus 8x plus 12. And we, because we put these two equal, and one was in the side, so this one will be equal to 0, and this one will be equal to 0. Why? Because to put all this in one part, you need to remove 2x from this side, and you remove 2x from the other side. You add 7 to this side, you add this 7 to this side. You will end up a 0 in this section, and everything will be in another part of the equation. Now we are looking at two numbers that can end up like, if you add them you will get 12, and if you multiply them you will get -8. No, it's the opposite. If you add them you will get -8, and if you multiply them you will get 12. And these two numbers are what? Like two numbers that add up to -8. I can say -6 and 2 and -2. Yes, these two add up to 8, -8, and if you multiply both of them you will get 12. So my answer my answer to this question will be x minus 2 times x plus 6 is equal to 0, and this means that x is equal to 2 or x is equal to minus 6. So this is my 2 point. Now you need to just substitute these x's in one of the equation. So for example, I will substitute this x in this equation. So I have x is equal to minus 2, so I know y is equal to x minus 7. I know my x is 2, so which will be 2 times 2 minus 7, which is 4 minus 7, which is minus 3. Perfect. So in this case, when x is equal to 2, when x is equal to 2, y is equal minus 3. I find one solution. The other solution is you substitute your x is equal minus 6. So y is equal to 2x minus 7 is equal to 2 times minus 6 plus minus 7 is equal to 5. So the second point, when x is equal to minus 6, my y is 5. So I just find 2 points. This is 1, this is 2. Good, perfect. So I have find both of them, and this exactly match with our solution that we find in example, the first question. So number 9, without solving the system, determine which solution is correct. For me to answer this question, I only look to one thing. Okay, I see that this slope, like this equation, this parabola is up, and this parabola is up. So both of them are up. Okay, these two parabola are up. This is 1, this is 2, and determine which solution. And I have a point, either a half and 1, which mean x is a half and y is 1, or x a half and y is minus 1. Okay, from my picture I just draw here, I can see this will not happen because my y will be negative. Okay, and I know my parabola, both of them are looking up, so immediately I will just remove this and I will not consider it. The other solution is to actually verify. You verify with your points. So I have x, this is x, this is y, this is x, this is y. So I will just substitute my x. So a half. So in our case it's not x and y, but it is m and n. So this is my m and this is my n, m, n. So the first one I will put a half square plus 7 over 2 times a half plus 5 times 1. And if I get minus 2, that means the question is, the answer is correct. But if I got something different, that means it's not the correct one. So my for both points, so I will use it for this equation and find how much it is, and find it is minus 2. And if I apply it in the other equation, I should find minus 7. And you can play with that and verify. So question number 10. Question number 10 is asking us to solve each system algebraically, giving exact answer. Explain why you choose that answer. Okay. For this question, perfect. So now the first thing I should do, always when you have question like this, the first thing you should do, look if they have the same power or not. If they don't, if they have the same power, try to cancel one by one. Like put one to in a way that will cancel the other one. But if they don't look like they don't have the same power, you put them equal. So I have P is equal to this and P is equal to this. I will put this is equal to this and solve for that. Let's do that. So okay, so I have 3k plus 1 is equal 6k squared plus 10k minus 4. I will take everything to one side, so I will have minus 3k minus 3k minus 1 minus 1, which will give me 0. Which will give me 0 is equal to 6k squared and 10k minus 10 plus 7k, okay, minus 5. So we have minus 4 minus 1 is minus 5. So this is equal to 0, and you need to look for, so you put this times this, so you put 5 minus 5 times 6, which will give us minus 30. I should look for two numbers that if you multiply each other, it will give you minus 30, and if you add them, you will get 7. So two numbers that multiply each other and can be added to 7. I can say maybe 10 and minus 3. So this 2 is minus 30, and if I have 10 minus 3, it will give me 7. So when I find them, I will come back to my equation and write it as this. So 6 is 6k squared plus 10k minus 3k minus 5. I will just rearrange it. So 6k squared minus 3k plus 10k minus 5. This is equal to 0. This also is equal to 6k times 3k, because they are both of them have 3. So 3k times 2k minus 1. And the other one is 5 times 2k minus 1. So I have 2k here, 2k minus 1, 2k minus 1. So I will just simplify that by this. So 3k, so 2k minus 1 times 3k plus 5. So I just got factorizing my equation. So my x's are, my solution are k is equal to a half or k is equal to minus 5 over 3. I find my k's, so I will just substitute one of them in this equation. So if you do that, let's take another color. So my p, so this one, this will give me, so p is equal to 3 times k is a half plus 1, which give us 3 times a half plus 1, which is 5 over 2. So if my k is equal to half, so if my k is equal, when k is equal to a half, my p is equal minus 5 over 2. I find one. I will proceed to find the other one. B is equal to 3 times minus 5 over 3, okay, plus 1, which is minus 4. So my P in this case will be minus 4. So this is my 2 points. I just solve my problem and find my 2 points. Okay, good. So for B, you can do the same thing for B. Just for B, let us do B because it is interesting. So remove all this thing and we will do number like 10B. So for B, we have 4x squared minus 3 plus 3y is equal to 1, and 3x squared plus y plus 2y is equal to 4. So can you see these two are mostly related to each other? So if I multiply this by 2 and I multiply this by minus 3, so I will be able to cancel them out. So let's us do this. So this will be I will multiply the first one by 2. I will multiply this equation by 2. So this will give me let's write it here, 8x squared plus 6y is equal to 2. And I will multiply the second equation by minus 3. This will give me minus 3 is minus 9x squared minus 6y is equal to minus 12. This is my system of equation. So now I will just add them to each other. So add this to this. So you will get how much? This will cancel each other. So this will cancel this. So I will have minus x squared from this side is equal to 10. That means my x is equal to plus or minus square root of 10. Okay, because why plus and minus? Because when you have x squared, you get two answers. So remember all that. Whenever you got x squared and equal to something, if you want to go back to your x, you need to square root the other side, but you get positive of it and negative of it. And now you got your x's. So first of all, you need to use your x in one of them. So apply your x in, like substitute your x in, for example, the first one, and you will find your y. And same thing, it is easy. I will just start and you can continue. So for example, I will go with plus 10. So 4 times square root of 10 square plus 3y is equal to 1. That means 4 times 10 plus 3y is equal to 1. That means 3y is equal to minus 39. Y is equal to minus 39 over 3. And if you divide it, it will give you 13, minus 13. Okay, perfect. And you got the first one. So when you have your x is squared 10, your y is 13, is minus 13. So you do the same thing for the other one. Okay, so for this question W, for the W question, you need to find the same thing. It's just whatever like way you use, it will be is good. Just try to make these two similar, like to have these two, both of them similar, so when you add them it will cancel out, or when you subtract them they will cancel out, and you will get just one of them. As long you have the same power, you can do that. But like the first one, you don't have the same power, so you cannot do that. I don't say you cannot, but it is very, very challenging to find the correct answer. So now, let's see which question we can do. We will have a lot of stuff here. So let's remove these things. Let's clean our board so we can have good. Okay, the approximate height h in meter traveling by golf. It's two different curve over horizontal distance. Given these two. Okay, the question is, at what distance is the ball at the same height when either of the clubs is used? Okay, this question is actually asking you indirectly to solve for this system of equation. You just need to solve it. So when this one is equal to this one, and when you put this one is equal to this one, that means you are putting this one is equal to this one, which means you are solving for the equation, for the system of equation. So we can do that. So minus 2, no, it's not minus 2, it's minus 2 to the power of minus 3 d square plus 0.3d is equal minus 4 10 to the power minus 4 minus 3 d square plus 0.5. So you put this one equal to this one. Then you can isolate all of them, put them all in one section, in one direction, and so minus 2 minus 3d square plus 0.3d plus 410 minus 3d square minus 0.5 d is equal to 0. So I have minus 2 plus 4, same thing. It will give me what? It will give me 2 to the power of minus 3d square. Okay, and I have 0.3d minus 0. It will give me minus 0.2d, which equals to 0. I will just factorize by d. So this will be 2 times 10 minus 3d minus 0.2 is equal to 0, which means d is equal to 0, or d is equal to 0.2 divided by 2 times minus 3, which is what? Which is d is equal to 100. Okay, please don't be confused with this 10 to the power of minus 3 that I am using here. It is just same as writing this. Instead of writing 0 minus 0.0002, I just write minus 10. Instead of writing this, I just write minus 2 times 10 to the minus 3, because this is same as this, same thing. So your answer will be either 0 or 100. And okay, the question B, what is this height? So this just tell us when d is equal to 0, that means there is no height. We do like the height is 0 meter before the bar is hit. So before we are hitting the bar was in the ground. Nobody touched it. So however, when d is equal to 100, like in this section, when d is equal to 100, that means the height is, you can replace with d. You can replace d with each value. So when you do that, you will find the height is how much. Let's do that. So I will just write this. So minus 0.002 times 100 square plus 0.3 times 100, which will give me so this is what, this is minus 2, so 0.02 plus 0.5 times 100, which is 10. So you get a 10 meter. So when the distance is 100 meter, the height of the ball is 10 meter for either the golf club. So so this question, let us look at question number 12. Manitoba has many biopharmaceutical company. Suppose scientists at one of those companies grow two different cells cultures in one identical nutrient-rich medium. The rate of increase S. So this is the rate of increase. So we are growing some bacteria in one scientific operation, and they notice that the rate of the growth, like the great rate, is given by this two equation. So the question is, what information would be scientists gain by solving the system of the related equation? So by solving this system of equation, the scientists will determine the time. So they will find the time when the both cultures have the same rate of increase of surface area. So they will find the time where exactly these two different growth rate will be equal. So the second question B is asking us actually to solve it. I show you how so many example. So you do the same thing, substitute this is equal to this and solve for your t. Like this is the first question actually. No, this solve the equation algebraically, and you can also solve it graphically just to double check if you got the right answer. Interpret your solution. I will leave that to English people to do that. Interpretation is not my my business. Okay, so question number what? This is just a paper where I can write. I think we are done with this section. So this is just the test question, the practice test. So we can start this little bit just to see what's going on. The graph for each system of equation is shown. In which quadrant is there a solution to the system? So we know the solution to the system is the intersection between the graph. So it will be in 2. So the answer will be B. The question. Yeah, let me go. Yeah. I think because be careful here. Yes. So you need to know something. Even the graph stop here, but it shows that it is still going up. So there is an arrow here. So this arrow show you that the graph did not stop here. And same thing, we have arrow here. That means the graph of the parabol also is not done yet. So continue that like this, continue it like this. So you can immediately see that there is two intersection. So oh my God. So you have one here and you have one here. Perfect. So the graph will actually touch in both, in 1 and 2. Okay, good. So the second question is the system y is equal to this. This is the system we have. So, and y has no solution. So they're telling me this and this system have no solution. How many solutions does the system have, this system? So the only difference between these two equations and this is here, the minus. So this one is looking down. So this one is a parabola looking down. This one is a parabola looking up. This one is a line with a positive slope. This one is a line with the positive slope. So if they told us that the first equation, this one, does not have solution, I will draw it like this. So my parabola is going up, okay? My parabola is upward, okay? Let me remove this thing. So my parabola is upward, and my line with a positive slope is like this. Why? Because they are telling me there is no solution. That means they are not touching each other at all. However, if I change my parabola from this section to this section like this, the only thing will change is instead of having my parabola looking up, it will look down. So this means that we will have two answers. So this will be number C. Question 3, table shown. Somebody did some job. Okay. The table of value shown for two different graphic function. What conclusion can you make about the related system equation? So the table of value of have 2 points. If you look here, 2 minus 3, this one, they are similar, and 4 minus 3, they are similar. So we can see the table of value have 2 points in common. So these 2 points are common. So the two quadratic functions must have at least these two real solutions. So you can say this, it will have at least two real solutions. They have no solution does not make sense. It has one infinite solution does not make sense because it has just two. It is a quadratic equation with a common vertex. No, we don't know. We don't have enough information to say that. So the answer is B. Number 4, which is here. Number 4. What is the solution of the following system equation? To solve this, you can graph both of them in your calculator and see how they are look. This one, the first one, is parabola. So you just draw it. You just graph both of them and have your answer just from your calculator. We don't need to do that. It's very, very straightforward. So if you want to do that graphically, algebraically, you can also do that algebraically by putting this is equal to this and you solve. But for me, a multiple choice question is better just to graph it and find the answer directly from your